So, number 1 in your warm-up says to name the legs of this right triangle. Which sides are the legs? BC is a leg, yes. And AB is a leg, good. The legs are the sides that make up the right angle. So angle B is the right angle, so any of the sides that touch angle B, those are the legs. The legs are always the smaller ones. Alright. Next, which one's the hypotenuse? AC, good. The hypotenuse is always the one across from the right angle. So once you know where the right angle is, just look all the way across. That's the longest side. We call it the hypotenuse. Now, if I wanted to find the value for this hypotenuse, which is labeled X, what would I do? This is like late November, early December material. Anyone remember? A plus B something. Something, yep. Yes, A squared, B squared equals C squared. Good. That's called the Pythagorean theorem. And A and B are always those legs, so we'll have 5 squared plus 12 squared equals what we're looking for, which is X squared. And then you can just do the math. If you have a calculator, great. If not, I can help you through the calculations. This is the only calculation we're doing today, so I don't mind giving you a hand. When you square 5, you get 25. When you square 12, you get 144. When you add those together, you get 169. And then that's X squared, but I want to know what just X is. So what do I have to do to both sides? It looks like division, but it's... No. Now you're just yelling out math words. What is that called? It's a radical. Yeah, you got to take the square root of both sides. That gives you just X equals, and what's the square root of 169? It's a whole number. 13, very good. So our X value here is 13. So again, this is just a quick review of right triangles. The theorem we're learning today only applies to these right triangles, so it's nice to just review what you already know. Do you guys have any questions? Alright, today we're doing section 5.4. It's all about the hypotenuse leg congruence theorem, so your objective is just that, to use the HL. Hypotenuse leg is HL for short. So you're going to learn how to use the HL congruence theorem. So before we do that, let's just review real quick again these things you know about right triangles. You don't need to write these down. I'm sure you already know this. But if not, make sure you're listening. So anytime you have a right triangle, the first thing you need is a right angle, right? Number 1, make sure you have a right angle. Once you have a right angle, you need to know what's what, okay? In the warm-up, we talked about the hypotenuse being where? If I'm at the right angle, where would I go to meet the hypotenuse? The longest side. You'd walk all the way over here. This is the hypotenuse. The hypotenuse is always across from the right angle. Biggest side of the triangle. The other two sides we call the legs. The legs make your right angle, and they're the shorter two sides. Okay? So you got 2 legs, leg, and then over here is hypotenuse. Any questions? Alright, this is the information that I want you to write down. This is the new stuff. So this is our new theorem, the hypotenuse leg congruence theorem. This is just another way to prove that triangles are congruent. So we already have side, angle, side, angle, side, and now this is the final one we're going to put on the list, the HL theorem. So HL theorem states that if you have 2 right triangles and the hypotenuses are the same, 2 of the legs are the same, you can say the triangles are congruent. It's kind of a variation. Remember I said you can't have angle, side. This is kind of a variation of angle side side. The only time angle side side does work is if it's a right triangle. So, 3 things you need to look for. 2 right angles, congruent legs, congruent hypotenuse, and then you can use the HL theorem. So go ahead and write this down, get the pictures in your notes, and let me know if you think of any questions. Alright, here's the first 2 examples. You can just watch these. We'll talk through them, and then on the next slide you can try some on your own. So, part A. The first thing we need for HL are right triangles. Are these both right triangles? Yeah. Even though this guy is not labeled, remember anytime you have perpendicular lines, there's a right triangle formed on each side. So if it was extended, you'd still have 2 down here. But these are definitely both right angles. So we do have the first piece of information. They're both right triangles. Do they have matching or congruent hypotenuses? So across from each right angle, do those sides line up? Yeah. Do they have matching legs? Yeah. You can see that BD is a line segment that makes up a side of both of the triangles, so they have to be congruent. So we have 2 right angles, 2 matching hypotenuses, 2 matching legs, so this would be a yes, you can use HL here. Part B, again, 2 right angles. That's good. I see matching legs because it's the same segment. EG is in both triangles. Do I have matching hypotenuses? I guess that's the plural. Hypotenuse? Hypotenuses. Anyway, do they match? Are they labeled as being congruent? No. So this one is a no. You have 2 of the things you need, but you're missing the 3rd one. What are your questions on these 2 examples? Alright, you didn't need those in your notes, but you do need these 2, so go ahead and write these. And then we're going to see if we can use HL. So again, as you're drawing them, check your 3 things. Right triangles, hypotenuse, leg. Alright, what are your thoughts on number 1? Do they have right angles? K's right angle. Where's the right angle on this one? Is it labeled as being right? Is it where 2 lines, like if there was another right angle over here, then you know this one would be right because they'd be perpendicular lines. But do we know for sure that N is a right angle? No. Maybe it's an 89-degree angle. Maybe it's a 92-degree angle. We don't know. So this is one's a no. It's actually missing the first important piece of information for HL. They have to be right triangles. Alright, let's move on to number 2. It says in the directions that QS, so that's this segment right here, bisects RT. What does it mean to bisect? When something's bisected, what's created? Yeah, 2. Bi means 2. So if it bisects, it actually makes 2 parts that are equal. So each side of that long segment is going to be congruent. So RS and ST are congruent, and I know that's because of this information right here. So now, are they right triangles? Yes. Do they have congruent hypotenuses? Yes. That's these guys right here. Do they have congruent legs? Yes, that's these guys right here. So can I use HL? Yes. 3 yeses gives you a yes. Wonderful. What questions do you guys have on this? All right. Now, I just want you to put 1 through 7 in your notes. Don't draw these triangles. We're going to talk about them in just a second. It's a lot of drawing. I mean, it would take you like half of the time we have left to draw these. So just go ahead and write in your notes 1 through 7. Leave yourself a little space for answering, and then we'll just talk through them. So the directions say, does the diagram give enough information to prove that the triangles are congruent? If so, state the postulate or theorem you would use. So if it's a yes, you can write yes if it makes you feel good, but you can just go ahead and name the theorem. The only time you'll say no is if it's a no. So if there's a theorem, state it, or put no if not. All right, number 3. So potential answers are side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, or none. What are you guys thinking for number 3? It is not none. What am I given? Right angles. Anytime you see right angles, you should check HL. Does HL work here? Yeah, we know the hypotenuse, we know the leg for each one, so this one is a yes by HL. If you want to put yes, you can. If you want to just put HL, that's like assuming that yes, they are. All right, number 4, there's a bit of a trick. You need to recognize that these are vertical angles, and vertical angles are always congruent. That might help you out. Any thoughts on number 4? What do I have? Angle, side, angle. Matches with angle, side, angle. So what's the answer? ASA. Good. Angle, side, angle. Now, number 5, there's a trick as well. You need to recognize that these lines are parallel and that MK is a transversal. These are the tricky ones. Anytime you have a transversal, it will form some congruent angles. Those are alternate interior angles. Remember, these are kind of hard to spot, so if you have a problem like this, I can usually give you some assistance. Just bring it to my attention. I'll help you label the right ones. But anyway, those angles that I just labeled, we know. We know these angles. Is there anything else we know on number 5? They're parallel. That gave us the angles, so we already used that information. Is there anything else we haven't really talked about? What's congruent? Someone said M. What goes along with M? M. It's a segment that's in both triangles. Yeah, do you see how MK is a side of both triangles? It's congruent to itself. So you have to realize that those sides are congruent as well. So now what do I have? Angle, angle, side matches with angle, angle, side. So this one is AS. That one's kind of tricky. Lots to notice about that. All right, number 6. Again, there is a segment that is in both triangles. What is it? Anyone see it? Wake up. XY. XY is in both triangles, so it's congruent to itself. Now what do you have? Side. 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 Yep, all 3 sides are congruent. So this is side, side, side. And then number 7, again, we have a pair of vertical angles. If you label those, it will make it a lot clearer what's going on. Anyone see what's going on? What do we have? Side. Angle. Side. Good. So none of these were none. They all are congruent triangles. We now know 5 postulates or theorem. There's 1 of each on the board. So you have side, 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 angle, side, angle, side, angle, side, angle, angle, side, and then the new guy, number 3, HL. What are your questions on this? All right, homework time.